Okay, hi everybody, welcome back. So now we're going to solve the first exercise, the deterministic solution, the deterministic scenario. So if you'll remember, he gave us the scenario that we want to retire in 20 years. We think we need $1 million to do that. So how are we going to do that if we invest 50,000 in assets today, and that will contribute an additional $18,000 every year? And we're investing it in the S&P 500 fund. So if you remember, the deterministic analysis was to uh, do the analysis using the arithmetic rate of return and the geometric mean rate of return. So we're going to go ahead and look at both of those real quick. So first, if you remember the solution that he worked through us, we had these rates right here. And these are real data rates from the S&P 500. So I'm not going to go through this too heavily because we did this in class. But here is the arithmetic mean, which we can use using the average function in Excel. So the geometric mean here, this is a part that I know threw many off. So we're just going to go ahead and go back to, let me close this out. We're going to go back to the slide here real quick when we solved for the geometric mean, and we had here that the geometric mean is equal to the product of all of the 1 plus r's to the nth power, where this here is the geometric mean function in Excel, minus 1. And just notice here how these are identical. We have here the geometric mean, which is all this symbology right here. The 1 plus r is the actual number that we're doing the geometric mean on. And this r of I that's here is all of these rows right here. And then the minus 1 at the end that we have in this equation is just the minus 1. And just real quick, what that minus 1 is doing is it's actually turning it back into a percentage. Look what happens when I don't do a minus 1. So right now, this is at 7.54%. It's saying that the average rate of return according to the geometric mean was 7.54%, which means that our portfolio grew 107.5% every year. So if I take away that minus 1, you see it shows that our average growth rate was 107% per year. But I don't want the multiplication number. I just want to know what the actual growth, what the actual percent rate increase was. And you'll notice when I did that now that this number shows it's not fitting. And so when you see these hashtags in Excel, it just means that the column doesn't fit. There's too many numbers for the column. There's two ways you can fix it. You can either just resize the column, which is kind of annoying. I don't really like that. So when you have a number here, like we do in the geometric mean, you can just go back home in Excel. We can decrease this number here. We don't need all those decimal points anyway. So when you see those hashtags all the way across, you know you either need to resize your cell or you need to decrease the decimal point. Okay, so that is how this geometric mean got set right there and what the meaning of all these numbers are. And it came from this derivation that we did over here. So now we're going to use the final value function in Excel to calculate what the expected rate of return would be, what the expected value of the portfolio would be at the end of 20 years using the arithmetic mean and using the geometric mean. And this here is the FV formula that we talked about over here. And you'll notice that I applied the negatives in front of these numbers here. So that's why those negatives are in front. And this allows us to set the contribution and the initial asset value as a positive number instead of a negative number, which is more intuitive from what we're talking about, and still use the formulas and have things clear when you're looking at it, because we can hide these negative signs under the hood. this next part that I'm going to talk about is kind of part of the solution, but I just want to show that there's a bug in this version of Excel, at least, with this geometric mean. And we talked about this after class, but I just want to highlight it here that this is in fact a bug. So if you see all these hashtag references right there, you thought you did everything right? Well, you'll notice if we were to go 0754, which is the same number we had before, and we plug this number in to the geometric mean, all of a sudden this starts working. For the most part, I actually don't know why those other didn't work, but this is a bug in Excel, I believe. If we actually just kept it at the if you keep it at geometric mean and you use this what if scenario, all of these numbers go haywire. But interestingly enough, when we leave this number alone and we just reference it from another spreadsheet and then do the what if scenario, it works. So that's why I'm pretty sure this is just a bug in Excel, and I left this here. But note that if you're doing this what if analysis and you are doing array math in another part, you're going to have to copy it to another spreadsheet. So what does that mean for you? It means if you see a bunch of refs, consider that you might need to just create a second sheet with the numbers. Okay, so we did this in class, and I'm going to go ahead and do it again here just so people can see it so they're comfortable with the solution. So we're going to so we have our values that we want to modify. On the row axis here, this is the contribution we're going to vary. And on the columns here, this is the mean, the rate, the average rate that we're going to vary. And here, it doesn't really matter which equation you use, the arithmetic or the geometric mean, because ultimately, we're substituting in this mean value anyway. So we're not going to use either the arithmetic mean or the geometric mean in this formula. Rather, what this formula is using is actually the final value function in Excel. And what it's doing is it's doing a variable substitution. Every time it sees the cell B11, it's going to make a substitution. And every time it sees the cell, which one was it? B9 or B8, it's going to make a substitution. So I'm just going to go ahead and pick one of them. I'll do the geometric mean. So this one here is going to be equal to B15. And then I'm going to do that little trick where you do Command-Shift on a Mac and Command-Shift down, Command-Shift right, and it quickly highlights all of those cells. I'm going to go to Data. We're going to do the what if analysis, a data table. And now this is where the row input table, the values that we want to substitute on the row, is going to be this value, this contribution. And then the column input cell that we're going to vary using these new rates is going to be the geometric mean number. And the only thing you want to make sure is that if you use the geometric mean formula, reference this in this cell, if you use the geometric mean, you want to call out the right cell. If you use the arithmetic mean, you would call out the arithmetic mean cell. It's the only difference between them. Otherwise, it doesn't matter which one you use. Just be consistent with whatever it is you pick. And here we get our solution. There we go. All right, just took a second for it to calculate everything. I have a pretty full workbook. So this is the same solution as we got in class. And then we can go ahead and format some of these values here. So I'll show you how to do that real quick. Maybe some of you want a little refresher. This little paint icon here gives you a palette that you can quickly do things with. So I'm going to go ahead and use blue palette for that. And then what Dr. Tsay did is for every number under a million, he colored with a red background. So I'll go ahead and do that as well. There, Control Y kind of redoes what you just did. And then I'm going to color these cells with a green background. Okay. And so now this kind of answers the question of, starts answering of if you're addressing the risk, like what is the probability that I'm going to earn over $1 million? And you can start to see that. So if you put in less than $18,000, your probability of getting $1 million starts to drop quite a bit, which again makes intuitive sense. And if the interest rate goes higher, then your probability of earning more than $1 million also increases. So a lot of this makes sense, right? But it's not a great answer. It turns out there's a better answer that we can get to using Monte Carlo simulation. And so that is what we are going to talk about next. So I will see you in a few minutes in the next video.